We're going to start with something called the tangent ratio. Yes?
Did you say this was next week?
Yes.
Big Friday next week, probably?
Next Thursday.
Oh, that's quick.
It is quick. It's not a lot of material. So the hope is, I believe it's the last test that will be on this mark period. We will have one more test before spring break, but I believe our last test will be just after, because it'll be like the Thursday before break, which just happens to be just after the mark period ends. Yes.
How many lessons is this?
1, 2, 3, 4 lessons.
4? Okay.
4 lessons. All right, we're starting with tangent. And we're also going to want our calculators. We're going to have a slight calculator sections. So make sure you have a calculator, and we're going to talk about the modes and the calculator. So all trig is just ratios that deal with right triangle. So our trig ratios is a ratio of lengths of 2 sides of a right triangle. And I'm going to put that again. Because the trigonometric, which we often call just trig, I'll shorten it to just trig. It's a lot easier than saying trigonometric every single time. But our trig ratios only work with right triangles. So anytime I'm talking about trig, I am just talking about right triangles. Once again, it only works with right triangles. Not wrong triangles, but right triangles. You do not use the right angle when working with trig ratios, and you'll see what I mean very quickly. All right, let's go through this. All right, our tangent ratio. What it is the tangent of angle A. Remember, angle A would be some degree. Maybe it's 30 degrees, maybe it's 40 degrees. The tangent of that degree is going to equal the leg opposite the angle I'm looking at over the leg adjacent. So it is opposite over adjacent. So if we look here, this is a much better way to look at it. So I'm looking at this right here. Tangent of A equals opposite over adjacent. So if I'm looking at angle A, the opposite leg is the one where I could draw a straight line. Let's go ahead. Opposite would be the one I can draw a straight line to, would be the opposite one. Adjacent is the one that's connected there. We know we're not using the hypotenuse because I would specify hypotenuse. That's how you know the adjacent one has to be this bottom one. It can't be this hypotenuse here. Hypotenuse is always hypotenuse. I don't ever call it adjacent or opposite. So our adjacent is always going to be the side that's connected to our angle. So this is opposite. This is over adjacent. Let's work through these problems down here really quick. So we have tangent B equals, so we look at angle B, and we ask ourselves, so if I have angle B right here, what is the opposite side? Yes?
What would it be over A?
It would absolutely be B over A, because the side opposite would be this one opposite if I draw a straight line. So that would be B. Let's do it in black, lowercase b. And then our adjacent would be the one connected to it. Now remember, do not accidentally do this and say it's C, because C is my hypotenuse. We're not using our hypotenuse at all. Our adjacent has to be that A. So it's B over A. And it definitely matters what angle I put here, because now I'm talking about tangent A. Can someone tell me what tangent A is going to equal? Amber?
A over B.
It's going to be A over B. All right, my next one is a right triangle, so I can use trig. What is the tangent of x? Someone new, give me the tangent of x in this triangle if I'm talking angle x. Stephen?
12 over 5.
It is going to be 12 over 5. Perfect. Because if I'm talking about angle x, we're talking about opposite, which would be 12, over adjacent, which would be our 5. Grace?
I didn't understand that. I was confused about where you said it.
Oh, yep.
Choose like the letter.
Yep, the letter we're talking about. So Grace, Can you give me the tangent of y then?
5/12.
It's going to be 5/12. Now is the time to ask, is anyone confused at where I got these ratios from? Yes?
I just have a question.
Yeah.
So will we ever have it like asks us like what's the tangent of z?
No, because we go back to
Is this the
this fact, you do not use your right angle when working with trig.
Okay.
You will never, ever use that right angle because we already know it's 90 degrees.
I missed that.
Trig does not work on this because it's already set at 90 degrees.
Well, then
Trig only works with your two other angles. That's a good question.
Isn't it because it's also is it also because it's a hypotenuse too?
Yeah, the hypotenuse would be our opposite, so it throws everything off. Because the opposite would be the hypotenuse. I will never ask you to do trig on a right angle, and that's why we put that right here. You do not ever use your right angle when working with trig ratios, because we already know that value. So you always have to pick one of those two other angles to work with. All right, we're going to come down here, and it says find x using each angle. So we can actually solve for the degree of, we can actually solve for the length x using, first we're going to use your calculators. I'm sorry, I completely biffed on that one. I thought we did it for a second. All right, calculators. Your calculator needs to be in degree mode. Now let me grab mine, because each of you is slightly different, and you can know if it's in degree mode. It should say, so if you're using mine or something like that, on the very bottom of mine, on the very bottom, it will either say degree or it might say rad. It's very, very tiny on mine. And if you're not sure, we'll do a problem and you'll see if you get the right answer or not. If it's not in the right mode, you should have some kind of button that says degree. Mine says DEG on it. And it should, when you push it, like change something. It should change it to either degree, radian, or so forth. The other thing you might have is a DRG button. The DRG button will go from degree to radians to gradians. Make sure yours is in degree, and we'll know right now if it's in degree. If you're using my type of calculator, to do tangent of 74 degrees, I need to type in 74 first, and then I have to hit tangent. Your calculator, you might be able to put tangent in first, and then type the 74 in. Just try right now. Yeah.
We don't even like.
Yeah, if you have a TI calculator, you're going to hit tangent.
Oh, you don't even have it in degree mode.
Yours is, if you're using a bigger one, you are... so see this degree right here?
Oh, okay.
You see that degree? Yours is under mode.
Okay.
So if you're using a TI anything calculator, you actually have to hit a mode button. Sabrina.
I'm on mode and I have it, but I don't know how to click it. Like,
Oh, it is clicked then. If it's not clicked, so watch. Now you have radians clicked.
oh.
So if it's not, now you're in degree mode. So you are in degree mode.
This mine's dead, but
Yours is dead, yes.
so.
Yes, yours you'd have to hit mode to make sure it's in degree.
Okay,
And then you would just hit your tangent and then the button.
I
But you're
figured
using
out.
one of mine. Okay.
Yeah, you just clicked
Yep.
it. Yeah.
All right. Yes.
How do you get to tangent?
You should have a tangent button. Let's get out of here. So see these sine, cosine, tangent button right here?
Oh.
You're just going to hit tangent, and we're doing 74, close parenthesis, and there you go. So everyone try to find the tangent of 74 degrees. You should come up with, oh, mine's off, 3.5, 3.48, 3.49. I just rounded to, yeah. Did anyone not get 3.49 on their calculator that's in the wrong mode, or they're just not sure how to input it? Jacob, are you okay?
Nope.
You're just fussy. No?
Nope.
Do you need help real quick?
I'll just use a different calculator. You have to. Did you find it or no? It's too sophisticated.
Yeah.
I blame it on Olivia.
Yeah, I don't know where the mode is on this calculator.
Yeah.
Is it the fancy one?
That's just
Yeah.
yeah.
Are you just in the wrong mode?
I don't know. I just well,
Yeah, you are in
this is why I
radian
have
mode
to
right
find it,
now.
like, yeah.
So your tangent button would be in here,
Okay.
but I don't know right now. I can help you later to figure out how to get to the mode. I don't know how to get to the mode on this one. Just use one of my crappy ones. All right, so tangent of 74 degrees is 3.49. What is the tangent of 20 degrees? Yeah. 0.36. Did we all get 0.36?
Yeah.
What was that even? Oh, fancy. Yes.
Will that seeing we have everything degree mode, will that mess anything else
No. Just stay in degree mode. You
no,
won't
but I'm
get.
saying for other calculations or no?
No. All right. Our next thing says find x using each angle. So we're going to start with angle 50 or the 50 degree angle. So what we're going to do is we're going to write tangent of 50 degrees. Well, tangent of 50 degrees is going to equal opposite over adjacent. My opposite is x. My adjacent is 27. We now have an equation where I need to get x by itself before I plug it in the calculator. So what we're going to do first is we're going to multiply both sides by 27. So I'm going to multiply both sides by 27. So we'll have 27 times tangent of 50 degrees is going to equal x over 27 times 27. Our 27 and 27 are turned to 1. And I'm just going to change the side the x is on. So we're going to have x equals 27 times tangent of 50 degrees. Now we're going to let our calculator do the rest. We are just going to type in 27 times the tangent of 50. Remember, if you're using one of my calculators, you have to hit 27 times, and it seems kind of counterproductive, you have to hit 27 times 50 and then hit the tangent button if you're using one of mine. Yeah?
Can we just hit tangent from the beginning? Can we just find...
The tangent of 50. Just do it this way.
Well, no, but so we can't just start it off by finding...
No.
Oh, okay, so...
Put it all into your calculator at once, otherwise you're rounding at weird places and you're not going to come up with the same answer as me. So I came up with 32.2. Yes, Sabrina.
Oh, I rounded it up to 18. 32.18.
32.18. Oh, yeah, that's fine.
Oh, okay.
Yeah, because I didn't specify what you had it rounded to. I'm just going to do 32.2. Generally with lengths, you do it to the 10th.
Yeah, I had like 2. So you do
7 times 50. Now hit tangent. Now hit enter. There you go.
Oh.
All right, 32.2. Did anyone not get 32.2?
I didn't get anything.
We have too much stuff going on. I just want to make sure. So you have to hit, did you do 27 times 50? Now hit the tangent button.
Wait, this is
Yep.
okay.
Now hit enter. There you go.
That's nice.
All right. Our next one is use the 40 degree angle. So if I'm using the 40 degree angle, we'd have tangent of 40 degrees is going to equal, now we're going to have something a little different because now I'm on the 40 degree angle. What is tangent of 40 degrees going to equal? Grace?
27 over x.
27 over x. So in this case, I need to get x by itself. So the first thing I'm going to do is I'm going to multiply both sides by that x. Maybe I should put that in a separate step. So we have x times tangent of 40 degrees equals 27 over x times x. These x's will cancel out, and I'll have x times tangent of 40 degrees equals 27. Now I'm going to divide both sides by that tangent 40. So our tangents are going to cancel out, and you're just going to have x equals 27 over tangent of 40. I want to stop right there. Did we notice something? Yeah.
Which is about the answer.
No, I just mean the tangent of 40 and the x. What happened to them? They just switched places. That will always happen if you have a whole number equals a fraction where you have x on the bottom. So you can shortcut this problem and just switch these two places. You could say, okay, if x is here, we're just going to swap these two places. And that it goes down to cross multiplication, because if I had tangent of 40 over 1, we'd cross multiply and they would end up just switching places. So this will happen every time you're solving for this. Yes, Sabrina?
So if the x is on the top, you would do it like that?
I do it like this every time if the x is on top. If the x is on bottom, you just switch these two places. Or you can do all these steps. There's nothing wrong with doing all these steps. Just get these right. I remember the last year on the test, people would get this wrong because they'd multiply both sides by 27. They'd say this cancels out and they're left with x. Multiplying by 27 on both sides does not solve this one, does it? Because nothing cancels out. So if it's on top, like Sabrina said, then multiply both sides by 27. If your x is on bottom, then you do this method. That's why I'm showing both methods to you. All right, so we have 27 over tangent of 40 degrees. Does someone want to tell me what that equals? Amber.
32.14.
So we once again have 32 point. Isn't that weird? That no matter what angle I pick, I come up with the same length. They should be the same. It'd be weird if one of them was a different length depending on the angle. So no matter what angle you pick, as long as you don't pick the right angle, right, Evan? We have to pick either this one or this one. We can solve for x, or that 27.
Pick the wrong angle, then you won't get the right answer.
Okay. All right, let's continue on. Now we're going to talk about the inverse tangent ratio, and talking about it doesn't do it justice till we actually get to it. So let's go through this. So the tangent function tangle? What happened there?
Angle.
The tangent function let's cross it out. Tangent of angle theta. What did I mean to put there? All right, the tangent function, or TAN, takes. That should be takes. I see what I was thinking in my head. All right, there we go. All right, the tangent function tan takes your angle and gives you out opposite over adjacent. In other words, tangent of 50 degrees gives you opposite over adjacent. The inverse tangent function, tan inverse, that's how we is on your calculator as well, takes the ratio opposite over adjacent and spits out an angle. So we use the tangent function to find a missing side. We use tan inverse to find the missing angle. So we use tangent to go from angle to side. We use tan inverse to go from side back to our angle. And here is my example of that. Here's my kind of example of that. So if I did on this one, if I did tangent of 35 degrees, that's going to equal 2.8 over 4.0, because tangent of an angle equals opposite over side. Now with tan inverse of 2.8 over 4.0 is going to equal 35 degrees if you plug that in your calculator. Now what I want you to do right now is look above your tangent button. Above your tangent button should have that tan inverse. For me, I have to hit the inventory button first to get to it, so usually I have to hit a secondary button. What I want you to do right now is to check. See if you can do 2.8 divided by 4.0 and take the tan inverse and see if it comes out as 35.
Wait, so tan and then the IMV?
Yes, so you're going to hit the blue button.
Oh. Before you do the tan?
No, we have to do 2.8 divided by 4 in your calculator. And now we're going to hit the blue button, and that will lead to our tan inverse. And you come out to 35.
What if it's not exactly 35?
We've rounded up to 35 degrees. So
We have to put that
these are rounded values as they are. It's hard to come up with unless I used a Pythagorean triple. But it's more interesting if it's not a Pythagorean triple. Did we all get about 35 degrees? Akshay, did you get 35 degrees?
Yeah, I got 34.9.
Yep. Sabrina?
Oh, we have to solve this?
I said we should try plugging this in our calculator to make sure it comes out as 35 degrees.
Sorry.
The next part says, find the measure of angle B and angle A to the nearest tenth. So what I'm going to look for, how I'm going to do this, is I'm going to first write tangent of B equals opposite over adjacent. Are we okay with tangent B equaling 20 over 6? Opposite over adjacent. Are we all okay with that? Notice the B is buried inside of here. We use this method to find something missing over here. So if my B is ever inside of here, we're going to switch the form to the inverse. If this is true, if this top row is true, then this is also true. Tan inverse of 20 over 6 equals my B value. So I was kind of in your head, start with this, thinking about this. And then if this is true, we can rewrite this as the inverse. So if we're ever looking for an angle, we should be using our inverse. So let's go ahead and plug this in our calculators, if you haven't already. What was that?
Like 73.3.
Mm-hmm. It does say to the nearest tenth, and I will give you the answer so you can see if you got it right. You should come up with angle B equals 73.3 degrees when rounded to the nearest tenth. Yes? Yes. Did we all get 73.3 degrees? Let me know if you don't know how to use a calculator, because that's going to really hinder your progress in this. Everyone, eyes up here? I just want to make sure. Did we all get 73.3 degrees? Stephen, no? Okay.
Yeah, I got 80.
Yeah, I got 82.
Let's go through this. So we're supposed to do 20 divided, 20 divided by 6, right?
Mm-hmm.
And then we're going to do our tan inverse.
Oh.
And then we're going to hit enter. Oh, no, I had it, didn't I?
Yeah.
Yeah.
Okay.
Yeah. So just make sure you do your 20 divided by 6 first. 20 divided by 6 first. And now hit your tan inverse. There you go. All right. Now we have to find our angle A. Do we not already know what angle A should be? If this is 90? We should already know it's 17 point. But let's just double check. So the tangent, 16.7, right? So we'll have the tangent of A would equal opposite over adjacent, but that only helps me if I'm missing a side. So instead we're going to write it like tangent inverse of 6 over 20 is going to equal my angle A, and type that in. What do you...
Points off if we, I know it says the nearest 10, but if we round down, we get,
just don't.
if we round down 73 and then we round up to 16.7.
How about we just round correctly, and then I don't have to worry about it, because that will be kind of a case by. If you do it every single time, then I'm going to start taking off points. If it just happened on one stray event. Yeah.
Is it supposed to be about 16.7 or equal to?
It's about 16.7, isn't it?
Yeah.
Yeah, but then you have equal to.
Oh, I'm sorry. That should be about 2. Sorry.
Okay.
You are correct. And we could double check to make sure everything's right, because 73.3 plus 16.7 should equal 90 degrees, which it does. So we are good. That's why I always calculate the other one. Even though we could just use 90 minus this, I always check the other one, because if they both come out, then I know I did the first one right. Yes?
We have ones where you could solve it and then say if it's like possible.
If it's possible? No, probably not.
No, you didn't mean by that.
Yeah, but I can always throw that in there.
You know.
All right, our next one is solve for the missing variables. So once again, If you're solving for a side, we are going to use tangent. So we're going to do tangent of 55 degrees is going to equal opposite over b. Now we can either do the multiply both sides by b, then divide, or we can just say, well, these two things can just switch places if it's on the bottom. So we are just going to have b equals 38 divided by tangent of 55 degrees. And who could tell me what b equals about? Akshay.
26.6.
26.6? Did everyone else get 26.6 that's tried it? All right, I'm going to let you do the next one. Let me just do the next two. And I will walk around and I will check to make sure. Just put the answers up so you can check, but I'll be walking around for help. So our R should equal 51.9 or about. So I don't think it's exactly. And we should have X is about 46.6 degrees. So those are your answers. I'll walk around and answer any questions. If you're having any problems with your calculator,